In today's lesson, we're going to look at multiplying polynomials. And we're going to start off by looking at multiplying binomials. So we're going to take two terms multiplied by two terms. And so whenever we multiply two things together, we can model this multiplication through area. Because we know if I ever have a rectangle, the length multiplied by the width of this rectangle is equal to the area of the rectangle. So whenever we have the multiplication of two things, we have area as a model. So here we have x plus 2 as our length or our width. So one of our dimensions, right? This would be dimension 1, which would be length or width, and this would be dimension 2 of the object. So if I ever ask for the dimensions of an object, you're giving me the length and the width. So we're going to now talk about this x plus 2 being some unknown length plus 2 units more. And then this is the same unknown length plus 3 units more. And we're going to represent that in this grid over here. So we can see that most times when I give this question to initially in class, and I asked for everyone to guess, what do you think x plus 2 times x plus 3 is? A lot of people say, well, I think you go x times x and then 2 times 3. And that's everyone's first initial guess, which is good. But we're going to show you in the model why that's not completely accurate. So in this model, we can see that the x squared is correct because when I look at this square right here, this yellow square, we have x times x, which is x squared. And now if I look down here at the rectangle down here, we can see that I have a 2 by 3 grid, so that gives me an area of 6. So if I said the area is x squared plus 6, I wouldn't be accurate because I'd be missing a whole bunch, right? What would I be missing? Well, I'd be missing this area and this area. Both those green areas would be missing. So now I have to figure out what those areas are. So since this is 2 units wide and x units long, this area is 2x. Or in other words, I have two areas of x area, right? X plus x. This is area x, this is area x, so I have 2 x's. And down here, same thing, I have 3 x's, right? So the area of this bottom rectangle is 3 times x. And we can also see that I have 3 of them here and 2 of these here, so together they give me 5. I can say those are called like terms, right? Whereas the x squared and 6 are different shapes, so they're not like terms. So the final answer is x squared plus 5x plus 6. So we were missing the 5x. So we have to figure out where does that 5x come from. So we are missing the 2 multiplied by the x, and we're missing the 3 multiplied by the x. So we were missing the 2 multiplied by the x and the 3 multiplied by the x. Or in other words, the first multiplied by the last, the second multiplied by the first. We were missing that. We had the x multiplied by x, and we had the 2 multiplied by the 3. So we can see there are 4 multiplications we need. In other words, you can see that this x has to go to both the x and the 3. This 2 has to go to the x and the 3. Okay, so it's like a double distributive law. So if I was to multiply this out, I would get x times x is x squared, x times 3 is 3x, 2 times x, and then 2 times 3. And then I would collect like terms, and I would have my final answer. That is the area or the answer to that product. So another way some people memorize this, I just showed you the beginning as like a double distributive law where the x goes to both and the 3 then goes to both. That's one way to do it. That's just what I do. But some people you may hear say FOIL. Well, FOIL just means the first times the first, the outer times the outer, the inner times the inner, and the last times the last. That's the same thing, okay, as my double distributive law. So I would get x times x is x squared, x times negative 7, 3 times x. Really watching your signs and being careful. A positive times a negative is a negative. And if it's negative, you would put subtraction sign, collecting like terms, and we would get x squared minus 4x minus 21. All right, so that is multiplying binomials. Okay, If it's a 2x squared, we're okay. We would just go 2x times x is 2x squared. I would get my 6x. Then I would get my positive 1x, which I just write x, and then I would get my 1 times 3, which is 3. Make sure this step here, we are multiplying, right? Our distributive law is always multiplication, not adding. So many people go 3 plus 1 is 4. So this is always multiplication. Once you're done, and what I usually do in talking in terms of math is I say this is expand, right? If you expand, you're multiplying out all the brackets. And then once you collect like terms is when I say simplify. So now I'm going to simplify. So I'm going to get 2x squared plus 7x plus 3. I collected like terms. So what my instructions would be expand and simplify. What happens when I have 3 things multiplied together, right? This would be a volume model, right? X times Y times Z. The volume has 3 dimensions, right? So when you're calculating the volume or you're multiplying 3 things together, like 2 times 3 times 4, it really doesn't matter which order you go. I could have done that to get 24, or I could have gone 2 times 3 times 4. I could have multiplied those first, and I could have gotten 24. So it doesn't really matter which order when you multiply. So for me, what I typically do is I ignore the 3 and I multiply those binomials first. You didn't have to, but I do. And so I just find if I put the 3 in first and then multiply my binomials, sometimes I forget my brackets and I make a mistake, or the numbers get bigger and I make silly mistakes. This is my typical way of keeping the numbers small and remembering that 3 goes in at the end. So I go 3 bracket, because it's still going to be 3 times the answer to that product. Now I'm going to double distribute, right? The x goes to both. The negative 2 goes to both. Whoops, I missed my x. The negative 2 goes to both. I collect like terms. Always simplify and collect like terms whenever you see it. It just makes it easier rather than going too far. Now I'm going to distribute that 3, and now that all my like terms have been simplified. Okay. What happens when we have a square? Please, please, please do not do this. You cannot square a sum or difference by squaring each term, right? That is only when it is a product. If you have a product, you are allowed to square each term. That is okay, but not with this, because we saw in our area model, if we just squared each term, we were missing parts of our area. So whenever it is a sum or difference and you're squaring or cubing or whatever power, there's no shortcut. There is no shortcut. You must write it out twice, right? The 2 means multiply it by itself twice, and then you do exactly what we were just doing. The x would go to both, x squared minus 3x, and then the minus 3 would go to both. Minus 3x plus 9. Be careful, a negative times a negative is a positive, which gives me x squared minus 6x plus 9. Please remember, if I give you the dimensions of a rectangle to calculate the area, you would multiply them, do exactly what we're doing. If I ask for the perimeter, however, perimeter is add up all the outside edges, or in other words, take twice the width plus twice the length, right? So know the difference between when I ask for perimeter and when I ask for area. This is a simplified expression for perimeter. This is a simplified expression for area. We can make it a little bit more complicated. What happens when I have negative 2 multiplied by something squared? Well, remember, we have to do our powers before we multiply. I could not distribute that negative 2 in and then square it. I must do my squaring first, and I cannot just square each term because we just talked about that. That is not possible. That doesn't make sense. And so instead, whenever I see a squaring of a sum or difference, I have to write it out twice. And this looks just like the question we had earlier, in which I said my recommendation is to ignore the negative 2 and to multiply that out first. So I'm going to get 4x squared plus 2x plus 2x plus 1. Careful, 1 times 1 is 1, not 2. Again, those are the typical mistakes I see. Now I can multiply the negative 2 in. Right? Oops, what did I not do? I just told you not to do it and then I did it. I did not collect like terms first before I multiplied in the negative 2. It's not the end of the world, end of the day. Sometimes our brain gets sleepy, but that's okay. I can collect like terms right now. It's probably better to do it up there. Keeps it neater and cleaner, but that's okay. There's my final simplified answer. All right, what happens when I have a binomial multiplied by a trinomial, or in that case, any size? It really doesn't matter. So basically, you have to take the first term, and it has to get multiplied by each and every term. So then you're going to end up getting 5x cubed, because we're multiplying, not adding, and then 10x squared, and then positive 5x. Now I need to multiply, and remember that negative goes with the 2. I'm now multiplying everything by negative 2, right? The sign in front always goes with it. Okay, so now I'm going to get, and whenever you FOIL, or I shouldn't say FOIL because there's too many terms here, whenever you distribute and multiply polynomials, the brackets will disappear, right? Same thing with the distributive law. Don't rewrite those brackets. And so now I go negative 2 times x squared, negative 2 times negative 2 squared, negative 2 times 1. Now I'm going to collect like terms. The 5x cubed, that's the only one. I have 2 of those, so I'm going to get positive 8x squared, and then I'm going to collect those ones. 5 and negative 4 is 1, so I'm just going to write x and then negative 2. All right. All right, in this next example, we are going to look at what happens when we have a power of 3. Again, please, please, please do not do this. Right? You cannot just cube that and cube that. When there's a plus sign, there's no shortcut. This question looks small, but this is really a big question. Whenever you see an exponent of a sum or difference, you have to write it out 3 times, or whatever that exponent tells you to do. So this is actually quite a long question because I have to multiply binomials and get the answer and then multiply by another binomial. It really doesn't matter which one you start with. I typically always start with these two just because I like to have my binomial up front, but it really doesn't matter. That's just what I do. So now I'm going to, and again, if it's a simple one, we can start to do a little bit in our head, right? So as I do this, I'm going to do the first one, which is x squared. And I'm going to do the outer product, the x times 2x times 2 and get 2x, and the x times 2 and get 2x, and I'm going to add that one in my head and know that 2x and 2x is 4x. That's how you can save yourself a little bit of work. And then 2 times 2 is 4. All right, rather than having to rewrite it all out just to collect those two like terms. It's your choice. Now I'm going to write the x plus 2 here, and now you can see this is similar to our last question where this x has to go to each one. So I'm going to get x cubed plus 4x squared plus 4x. Now this 2 has to go to each one, so I'm going to get plus 2x squared plus 8x plus 8. Now I need to collect like terms. Those go together, so you can see how you just have to write neat and tidy because it's so easy to make such a silly mistake here. Double underline, so I know those go together. Really easy to make this mistake because it's a very tedious question. All right, this is where a lot of mistakes happen. We have to be very careful because of this subtraction sign. So reminder, we have to multiply before we subtract. So when we multiply these two, let's do a bit in our head again. So we get x times x is x squared. Then we get negative 5x and positive 5x. Negative 5x and positive 5x add to 0x. I'm not going to write it. And then 5 times negative 5 is negative 25. So in this case, I get a binomial because my middle terms of my multiplication canceled out or added to 0. I'm going to keep it in brackets because this polynomial needs to be subtracted by the answer to this one. Okay, so I have to keep those brackets because of that subtraction sign. So again, I'm going to go x times x is x squared. Let's do the next two in our head. 6x, 2x is 8x. If it was more complicated, I wouldn't have done it in my head. And then 2 times 6 is 12. Be careful when multiplying, not adding. That's a number one mistake as well. Okay, so now we have subtraction. So remember, when you are subtracting, if I'd forgotten my brackets, we would think this was positive 8x and positive 12. But since we're subtracting, we have to subtract every term. So we have to do the opposite of each, right? Change them all to adding the opposite. Then we collect like terms. X squared minus x squared is gone. 0. I have a negative 8x, which doesn't go with anything, a negative 27, and sorry, negative 25 and a negative 12 is negative 37. So all of this becomes this. All right, and our very last question is pretty much the same question. The only difference is I have those squared first, so that just means you have to write it out twice. Write it out twice. And then do exactly what we were doing before, right? So you would get your 4x squared. This one's more complicated, so I'll write it out. So I get minus 6x plus 9, collect like terms, 4x squared minus 12x plus 9. And then I'm going to subtract, oh, this one's not as complicated. I'm going to do some in my head. X squared plus 5x is plus 10x, and then plus 25. Now I can change this to adding the opposite, and now I can collect like terms. 4x squared minus x squared is 3x squared. Negative 12x and negative 10 is negative 22, and 9 minus 25 is negative 16. There we go. So, unless I made a silly arithmetic error, but that is the final answer to expanding and simplifying polynomials using multiplication.